Welcome! In this video, Mark W0WMM tells us about space weather and its effect on amateur radio.
To clarify that, I'm a continuity planner, a professional continuity planner, emergency manager, and a disaster recovery person. To sum it up, last Thursday was Bring Your Child to Work Day, and I had to jump through lots of hoops to get my 10-year-old into the place I work. And it was interesting because I asked him at the end of the day, I said, you're going to have to give a report to your class. Please don't mention any of the following things. So I told him that. And then I said, so you're going to have to say, what is it that I do? And he said, oh, that's easy. You plan for the very worst day. And that's true. That's it in a nutshell. I plan for the very worst day. And one of the things that I have become interested in is space weather and how it impacts us. It's a lot more serious than we believe it is. And if we look at predicting space weather compared to terrestrial weather, we're roughly about 60 years in the dark as far as what we had in the 1950s for terrestrial weather is what we have for space weather prediction. We're way far off the mark, and so we're trying to get better. We're putting up more satellites. There are what they call stereo A and B, which are on either side of the sun. If you're facing the sun this way, on either side of the sun, there are two satellites that are monitoring the sun, watching for activity. There's also, so we're roughly 93 million miles away from the sun. There's one about 1/3 of the way in front of us that they're constantly tracking with Earth, and that one is our first warning system. If something bad is coming from the sun directly at us, that particular sensor that we have set up is going to give us the first warning. So I'll ask you guys, I'm not a physicist, I'm not an astrophysicist, so I'll try to stay at a level that all of us feel comfortable with, but I'll ask you the question. So how long does it take light to get from the sun to the earth? Anybody? Yeah, 8 minutes. 8 minutes is roughly the average time. We have roughly, if you think from 8 minutes out, and you think compared to when that particular sensor array that we have set up right in front of us, it usually hits that in about 5 minutes, and we have about 3 minutes after that. 3 to another 5, say. So that doesn't give you a lot of time to prepare. And so we're going to talk about what you need to prepare for. Let's see, I'm gonna have to...
I have a question. I'm confused.
Yes, go ahead.
What kind of radiation? Are you talking about electromagnetic radiation or coronal mass ejection?
We're going to talk about all of it.
Ah.
Yeah, because all of it's important. There's a whole bunch of different things that are going on, and I'm trying to find. This is a new version of PowerPoint here. So, and
the space bar.
And keeping it the same meant they couldn't have sold you the new version.
yeah. So when you ask average person walking on the street out there, what do you think about the sun? This is usually what people think about. Okay, they think of it's this yellow thing that is out there, when in reality this is what it really looks like. So you see that there's a lot of activity going on the sun. This happens every day, every minute. This is constantly going on. And we're not always exposed to what comes from the sun. Sometimes it goes out to the left or the right or misses us. But sometimes we do get to see what it is. And when we do get to see it, this is the visible effect that we see. Now, if you remember that very first slide, when you look at the Earth and the magnetic field around the Earth, think of a donut. So the donut, you're holding the donut, and there's a hole in the middle of the donut. That magnetic field kind of curves around, and so when you have all those charged particles that are hitting Earth, they just follow that curve down into either the North Pole or the South Pole. And that's how you get the aurora. The interesting thing, like the two that you see on the top, those were taken in Canada. The one over on the far right there that you see, that was taken in Iceland. I took that last October in Iceland. The one that you see at the bottom down there is in Florida. When you see an aurora in Florida, that's bad.
Yes.
That means that you've got a really strong solar storm that's happening. All right? The worst we've ever had is that in, I think it was 1920s, 1930s, they actually saw an aurora in Cuba. And so that was marked as one of the worst ones. So, the question that Dave asked a while ago, is it a solar flare? Is it coronal mass ejection? Backing up just a little bit, as far as when we look at what happens with this solar cycle, everybody's heard about the solar cycle. Usually 9 to 14 years, 11 is usually the average. We're on the tail end of cycle number 24. Cycle 24 was considered to be a low to moderate year. Not a lot of activity, not a lot of sunspots associated with that. 23, which was the previous year time, was much higher. They had up to 175 sunspots, which is a very active year. 25 is supposed to be even more than that. So, you know, sometime between 2017 and 2019 is when we will jump into the next solar cycle. So, the two things that happen on the sun's surface, we have solar flares. Solar flares are those bright areas that you saw a while ago, and they're where you have intense X-rays and UV exposure. This can be strong enough if you're at high altitude, if you're flying in a plane at a high altitude constantly, if you're in outer space, astronauts exposed to that, it's enough to be lethal. That's how strong it can be. Those are solar storms. The other one is called a coronal mass ejection, a CME. And all that is a large cloud of plasma that's being released from the sun and coming out. That plasma is charged particles. And when they hit, they charge the atmosphere, particularly the ionosphere is what they charge. Causes a lot of rapid changes. That's a geomagnetic storm. Now, what I'm going to talk about a lot tonight is the geomagnetic storm and how it will impact what we do as a hobby and also what we do as far as trying to provide, I guess you could say, a public service. And we'll get into that in just a minute. We've already talked about the cycle that we're in. The little factoid that I put down there was kind of interesting, that since 1859, the Earth's magnetic field has gradually shifted up to 20 degrees. So if you look at true north versus magnetic north and that shift, that's because of all of the storms that we've had. Mark? Yes?
Sunspots, are they considered the same as a solar flare?
Yes.
Okay.
Mm-hmm. Yep.
Another question?
Yeah, I'm sorry.
This bullet where you talks about cycle 25 is predicted to be much stronger.
Yeah.
I've read, who is predicting that? Because I've seen a number of predictions that, you know.
And this was one, I guess in March, I was at Johns Hopkins University at the APL, and it was a space weather symposium, and that's actually where I heard that. And it was some of the NASA folks that were, but I'm like you, and that goes back to what I said earlier as far as we know as much as we know, and so we're trying to do better as far as predicting like that. Yeah, here shows you, I was hoping I had this one in there, but here's the cycle. You can see in cycle 23, we had up to almost 175 sunspots. Here's cycle 24, and that red line should be shifted over just a little bit, but you can compare the two. There's a vast difference. So we'll have, you know, predicted value will be more like 23. Okay, here's what we know as far as warning time. We mentioned that sunlight hits the Earth roughly 8 minutes, all right? Solar flares, the X-ray part, all of the bad radiation part, usually between 8 and 15 minutes, give or take. And then all of the other stuff, the radio noise emission, that usually is between 8 minutes and can last up to 3 or 4 days. The charged particles, between 8 minutes and then out to about 3 days. And then the other part that we were talking about, the magnetic storm, that usually, you usually have enough of a time that it's usually 3 to 4 days after you have some type of event occur on the sun that you'll see that. And there are some great apps out there that I'll tell you about in a minute, because I have one that is that gives not only solar weather but gives some of the other things like pandemic planning and things like that. So you can pretty well predict when it's going to happen. And I know the other day there was a G2 level geomagnetic storm that was kind of interesting, because right before it, I had lots of DX going on, and then had to wait about an hour and a half or so, and then right after it, it was active again. So that kind of helps you with predicting. Geomagnetic storm history. Through carbon dating, we've been able to go back as far as 2225 BC. You'll notice that there's one right here in the middle, the 774. There was a red aurora that lasted for months over England, and that was like during the Dark Ages. So you can imagine that they associated that with witchcraft and all sorts of things, but they called it the Red Crucifix. And it's kind of an interesting article if you want to go and look at it. Then we have a whole bunch that were direct measurements, starting with 1859, which is called the Carrington event, and that's an important term that you'll hear a lot, and all the way through the Halloween storm, which was in 2003, and had lots of damage caused by that. So here are the impacts. 1847, telegraph operators noticed they cut off the power from the telegraph lines, but there was still voltage, still current on the line. So they started thinking, well, this is strange, you know, there's no power hooked up to it. How's that possible? In 1859, this was the Carrington event. It disrupted telegraph service worldwide. They were not able to transmit transmit or receive. Yes?
The records of the Western Union Company and 4 major railways put the damage at 81 offices set fire.
Yes, yes, yeah. So, I mean...
81 separate telegraph offices were set fire.
Well, and I don't know if I've got it in one of the other slides, but the reason why this happened is because you think about it, that all of these charged particles get on long wires. And think about, where do we have the longest wires? It's in our power system, in our electrical grid. We have long. Well, the power is additive, more or less. So it's usually 6 volts per mile. So you can imagine if you have several miles of power line and you add 6 volts each time, you're going to have quite a lot. And that's why the fires, yeah, that they can attribute to that. Some of the other storms that we've had in 1921, that's the one that I was talking about. Arcing caused fires, melted transformers, electrical wiring was just fused. 1989 was the Quebec power grid failure, in which major blackout occurred. That was due to a major solar storm. 2003, that's the Halloween storm that I was telling you about, interrupted GPS. So all of the synchronization of time, of navigational signals and everything, all of that was disrupted. You'll see there that in South Africa, they destroyed several of the huge transformers that they were completely just fried. And 42 satellites, and as far as telecommunication satellites, and I'll put a little asterisk next to that, valued at $640 million. The solar panels were damaged, and then also the electrical systems were damaged. Now, today, if we had a Carrington event, and that's the 1859 one, it would take roughly 4 to 10 years for us to recover. So you can imagine not having power for 4 to 10 years. That's something to think about as far as what are you going to do. Lloyd's of London put the cost at over $100 trillion to repair it. And part of this is because we've become so technology hungry in that everything we have is technology based now. We have lots of power lines. And somebody brought it up in one of the other talks that I did, said, oh, well, everything's fiber optic. Well, guess what? There is a metal cladding that goes along with that fiber optic. Oh. And yes, undersea cables, because it will go right up to the landing station and then go out and follow that, that cable. So, a little note at the bottom, question? No. Little note at the bottom there, the estimated time to make the decision for continuity disaster recovery activation is 10 minutes. That's what I told you earlier. So that's not a lot of time to say this is what we need to do. So here's some of the damage from both 1989 and 2003. And you can see the windings on the transformers are just, that's into an electrical box there that...
well, the other is a stator or on the generator rotor.
Mm-hmm.
That's the stator sector.
Yeah.
It was damaged.
Yeah. So...
How large of a generator are we talking about, just to get an idea?
Well, I mean, these are large transformers,
Okay.
Yeah, power plant,
Power plant size.
Yeah. Yeah, and this was part of a transmitter in Quebec that just totally you see things that are just burned black. Now one of the safety things that I'll tell you about that a lot of places are doing are having particularly BG&E, Pepco, all of the power companies are having what they call disconnects, where they can totally pull the big switch and isolate sections so that you don't have this type of damage that occur. But once again, that's that 10 minutes worth of planning. Is Bob going to be eating his lunch when this happens and not be able to pull the switch? So we're, things like automation, as far as if we detect something like that happen, can we have an automated system that'll
There's always somebody who is hesitant to do something because of the backlash of the public should you cut their power.
Yeah, that's it. That's exactly it. And that's when you need to remind them, it was made as a decision to keep you from having 4 to 10 years worth of not having power. So, yes?
Something to be aware of, that every single power outage that affects 100,000 people kills 7 of those people, okay? Every single 100,000, and that's not a prolonged outage. When a power outage occurs, 7 usually rather brittle people die because equipment they were depending on for their very life then failed.
Right.
So out of 100,000 people, you'll have 7 deaths from an ordinary power outage.
Good point. Okay, so how do we observe these storms that are coming our way? Well, I told you about SOHO and Stereo AB out there. They're putting up some new ones that are coming out. The last 2 you see here, ESP and Gong, they're revamping those systems to go out. ACE and XRS, both of those are active now, and data is coming in. In fact, and I can't remember the guy's call sign, but if you go out and you see there's one page that always has lots of data out there. And I think I've got the link, but you can actually pull down a lot of this information that's out on the web. A couple of different types of scales that you'll see. SWPC is the Space Weather Prediction Center in Boulder, Colorado, and they will issue based upon where you are. For this one right here, this is the radiation scale, and it tells you for biological, satellite operations, or other. It'll give you, you get an S5, then you know you're in trouble. Here's the radio blackout scale. An R3 will cause a wide area blackout of HF radio, and they'll put out a map also, a global map to show you where this is. I think I've got an example here in a minute. And then the last one is called the Geomagnetic Scale. And this is usually the one that I follow because it talks about not only power and spacecraft, but it also talks about other systems, and it usually has HF radio propagation in there as one of the things to look at. So depending upon where we are on that scale, and here's what one looks like. So, and I think this was in December. Yeah, this was December 29th. I caught this one, and it was a G3 storm. You can see it because as the storm moves, it moves like a wave coming in. So as the storm moved, it was pretty easy to follow it in that. So on the 29th is when the report came out. On the 30th, we had the strong geomagnetic storm, and then by the 31st, it was almost nil, nothing at that point.
One of these things those reports also provide is how far down in the latitudes you are going to feel the effects.
Good.
So that's very important.
Yeah, good point, because it'll tell you that it'll say higher latitudes, mid latitudes, and that's an excellent point.
I'm sorry, why does it, because of the Earth's temperature, why does it hit broadside?
Sometimes it does. In fact, it was really funny that I guess it was back in February, March timeframe. There was a storm that if it had the timing, and I think they said timing-wise, we missed it by 2 weeks as far as the Earth moving, that it would have been a full face-on type of hit rather than a glancing blow like that. Yeah.
Mark?
Yes.
Can you explain again? So the effects of these things seem to be greater at the poles.
Yeah.
So you would think that since the equator of the Earth is closest to the sun, that would be affected the most.
Well, it's the atmosphere also. See, the atmosphere is one. It's thicker, you know, on the equator side, but also you have more of that cushion, more of the donut, is what I like to say. Versus at the top, it's open more or less.
Oh, okay.
Yeah. So, and there's also, if you go out to one of the websites and look at the Aurora map, it will actually show it from a down position, so you can see how it rotates across like that. It's very good for that.
Additional?
Yes?
I just had to point out one reason why the poles are affected more is because the magnetic field is actually diving into the poles.
Yeah.
So the stuff that's traveling the magnetic field lines actually comes in, and that's why the roar up here, where they do, that's where the ionosphere and the magnetic fields intersect, basically, as they come down.
Yep.
To the pole.
Yeah, and I'll put that slide back up in just a minute. So when the solar wind exerts pressure, it actually, the donut shape actually compresses so that you can see it move. And, you know, of course it generates noise on the FM bands. You can actually hear that very clearly. You know, I think we've covered part of that. VHF and UHF coming through the ionosphere, subject to dispersion and scintillation due to extreme event. And yeah, we talked a little bit about that, about the GPF. All right. I did have one other. This is the one I want to show. All right. So if you look at a normal radio spectrum from 1 to 30 megahertz, 1 to 30, this is a normal day. Okay, that you would see what would be happening, and you see what the time stamp is up there. Now,
What is the legend of the color reference to?
the red colors mean higher traffic, more dense. Okay. Now, watch this. This is when we had a geomagnetic storm, and look, you've wiped out everything down here between 1 and I don't know, almost 10 up there. This, when I looked at the full report, this line right here that even occurs out, this is 14, that's 20 meters. So, and then the other interesting one, and there's a study out at University of Purdue where they're looking at the fact that almost every time that you have one of these, this is 12 meters right here. And, you know, it's one of those weird things that, why would it be 12 meters? I don't know.
So does that mean that it's not affected?
Yeah.
Yeah.
So kind of an interesting thing. I'd love to try to test that to see, you know, if that theory is true. And I told you earlier, here's the map showing, this is a blackout that occurred. And this moves fairly fast. Within an hour, this is gone. So it's rather fast moving type of event.
Mark, you talking about magnetic storm or solar CME?
This is a geomagnetic storm.
Okay.
Yeah.
Was 2003 also?
Yeah, exactly. Yeah. And these are just common facts that are out there. You know, if you're in a QSO, you know, don't QRT because of the fact that it's going to pass within an hour or so. Good DX contacts are possible immediately following a solar flare. You know, just some of the common facts that we've learned. And, you know, there are no, I've learned one thing with this, is there are no hard and fast rules. There are things that sometimes they work and sometimes they don't work. So you just kind of have to go along with that. Got one more, propagation factors. You guys probably know about that. The national policy. All right. This is the stuff that I think the club would really be interested in. In October of 2015, the White House put out a National Space Weather Strategic Plan, and then they put out an action plan. And guess who is mentioned in both of these? Amateur radio service. So, it's a place for us to fit in during emergency operations. There's a NCSD 310 talks about the U.S. government leveraging existing communications, including amateur radio operations. There's a Department of Defense instruction that, of course, they talk about using Mars, but they would go to other avenues. Of course, FEMA through Part 97 talks about amateur radio service being the go-to. And all of these authorities, this is what the government is using, they're leveraging, saying, all right, if you are an emergency planner, you work for the government, then you should be a licensed amateur radio operator. So that's the stick that they're starting to use. And, you know, of course, we have our trainer here that, you know, we can say, yeah, sign them up. So, some of the, here's the one, the call sign that I was talking about, SolarCam.com. All of these are great places to go out and get information. There's a couple of apps that I mentioned, and I don't see them on here, but I'll make sure if you're interested in them, I'll get those out to you, so that now, what can the Art Club do to prepare? Do we have an emergency plan? Okay, that's fine. That's a valid answer. I will raise my hand now and volunteer to develop one for you guys. Yeah, because I'd like to be able to say, you know, we have, you know, somebody say, you know, what's your plan, and say, here it is, we've got it. Yes?
Yeah, I'd like to suggest too that you maybe get in contact with Al Taylor, KN3U, since the Auxiliary Communication Service, which is very sort of separate, but does have the tie-in to the county.
Right.
That would be really another place, because that stuff would get, you know, tied into what the county's doing.
Right. Excellent point.
And also, Jim Montgomery and Wanda Montgomery are very active with the section, the Maryland and DC section of the league, as our amateur radio emergency service section emergency coordination.
Okay. Excellent. You know, if we do have a major solar event, prepare to support, you know, local, federal, state, whoever. Provide support to the municipalities that you guys just mentioned. And one of the things that often gets missed is providing critical communications for medical services. Like, you know, 911's not going to be working. So that's a key thing that we can help with. So
when you say facilities, you're talking beyond the typical hospital radio networks that the HAM support.
Right.
Such as dialysis centers and...
Excellent point. Yeah, excellent point. Yeah, we were talking earlier about, so if we have a broadside strike, like you see that hitting, it compresses that front side, and so really all of those particles, charged particles, turn and go right into the poles like that. So, yeah, my son actually named this. I put this together, and he said, well, you know, it's a picture, it's got to have a name, so he calls it Shields Up. so I said, all right.
Speaking about Shields Up, there's actually geologic evidence that the poles have flipped. There's a period of time where we don't have a magnetic field, shields down.
Right.
And I heard or read that actually we're overdue for one of these flips. What do you know about that? And also,
well, actually, remember one of the slides that I showed where it showed that difference between true north and magnetic north, and it being a 20-degree difference, the more storms we will have, the more that will deviate, and it's quite possible that that could happen. Now, on the sun, these right here that you see, these loops, these are actually charged poles, and they usually mark them as N or S, and these are very, very strong, intense magnetic fields that are generated on the sun like that. So, could it happen? Yeah, yes, it could. You know, I gave a watered-down version of this talk to my son's school, and I actually had one of the kids say, well, if the poles flip like that, does it mean like the toilet will go in the opposite direction? It's like, no, I don't know. You know, that's you know, we'll start driving on the other side of the road. You know,
unless the rotation of the Earth stops, the Coriolis force is not going to be affected.
That's true. There you go. Good point. Okay. Any other questions? Yes.
The risk of an EMP, natural occurring EMP, which part of this is tied to an EMP?
Excellent
It's gonna hit our
question.
antennas and destroy our rigs.
Excellent question. Everybody always thinks, well, if we're having a CME, the coronal mass ejection, that's the same as an EMP. No. An EMP lasts 1 microsecond. It is a sharp peak that comes up, whereas a CME is one of these. So you're talking voltage, you know, on this scale and time. So the EMP blast will go straight up, straight down, last about a microsecond, whereas the coronal mass ejection, you know, the actual impact that you feel is a lot longer and gradually. So it's a slower type process
Is
like
it the
that.
CME that causes the EMP, or is there?
Now, an EMP can be caused by like an aerial nuclear blast.
I understand that, but I'm talking about naturally occurring.
Naturally
solar
occurring?
activity.
Actually, what is occurring with a coronal mass ejection is it's some type of reaction occurring on the surface of the sun. I guess you could say it's.
Well, I think what he's looking for is the lightning strike EMP effect that does occur, but it's a weaker form than what you have in a nuclear detonation.
True. Very true. Yep. So, yes, sir.
So how is it going to affect our cell phone service?
It will.
It will. Thank you for answering that. Yeah. So for cell phone service, you have to realize that only a part of that is radio wave, and you connect to a tower that is hardwired at some point in time, and so that tower is going to be impacted as far as damage to the wiring and everything.
The problem we have right now about EMP, for those that are interested in, might Google the SIGGUARD group that does EMP. It's very active in this area. They have meetings all the time, and the public is welcome. But the problem that is trying to be overcome is to get the industry, the telecommunications industry especially, to start hardening their facilities. That yes, we're going to have effects where the antennas may be damaged and so forth, and that can be repaired. But if you don't protect the interior equipment,
Right.
you're going to be spending years, not months, years, getting this stuff replaced and back up in service.
Yeah.
So if somebody wants to know about the URLs, I'll be available
Right,
afterwards.
and the planning for that is totally different. You plan differently for an EMP than you did for a CME. So totally different planning. Somebody had their hand.
Yeah, I had a question. So you have these satellite systems that observe what's going on the sun, and they send those signals back to Earth via radio?
Yes.
So
They're only seconds ahead.
They're seconds ahead.
So when these things happen, you're not going to get anything from them anymore, right? Because they're going to get hit first.
Yeah. They are hardened. Everything that's been sent up is hardened. So it's a little bit more protection than, say, the Telstar satellite that, you know, been up there forever. So, yeah.
Wasn't the worst case scenario for a CME was one that occurs out of sight of everything that comes around in the rotation and hits us head on? Can you discuss anything about that, or give some idea of what that scenario?
An event, rather, in 1859, that's what they thought happened, as far as that the great major storm. And the funny thing is that everybody said, okay, so it's a storm that, you know, has a 500-year, it's like the 100-year flood plan. Well, geez, if I just bought the house and so I'm on year 1, that's not the way it works. So, and it's the same thing with the Carrington event. You know, we're
satellites further out now that are going to
Yeah.
be able to pick this up a little bit sooner than it used to.
Yeah. So we've got stereo A and B, and we've got Soho directly in front of us. They just launched another one that's not in place, but it's going to go to the far side of the sun. So that's going to be C over there. And so between the three, basically, we'll be able to tell what's happening because the sun is rotating too. So if something goes out from the back side of the sun, we're not going to see it from this side until it, like you saw that wind pattern that came. So we could get hit from the side for something like that.
You raised a comment there, reminded me that I asked earlier, what is the definition of a solar cycle relative to the Earth's rotation or our year or annual cycle?
Actually, they've determined that it's based upon the sun rotation, and that is that 9 to 14 year cycle that you see. So it's the sun moving, not us. So, yeah. So a couple of other ones. Let me get back to the back there.
You've spoken of having these satellites, so we're going to have a warning. And what is it that we can do to protect us, considering we have this minute warning or 30-second warning or whatever? Is this
Unplug everything. Yeah, I mean, really, you know, it sounds like oversimplification, but, you know, power companies are going to start disconnecting. We need to disconnect ourselves too, so that we're off of the grid, so to say.
Our biggest vulnerability, if I recall correctly, was the primary transformers for the high tension transmission lines. And
Yes.
if they're not isolated, we will effectively lose that capability for several years.
Yeah. So, somebody all the way, yep.
Okay, it's actually kind of a double question that you deal with. What is it? Are we talking more latitudes, more to the north and more to the south? And are we talking more north or more south for events and the intensity of events like this?
Well, okay, look at the Carrington event. Remember I told you that, so, well, let's go back one. Let's look at the Halloween storm, 2003. That picture that was taken in Florida that had the northern lights or southern lights, however you want to look at it, that would be an example of where it impacts even lower latitudes, more closer to the equator, like that. So a very severe storm. So they think that the storm of 2003 was a G4 rated storm, not the most intense. The Carrington event was a G5 plus, so it was even above 5. So ones like that, it's going to be a global impact. It's not going to be, you know, higher latitudes or something like that. Yeah.
And the follow-up on this is, we always hear of the solar reports weekly, the A and the K,
Right.
flux index. What kind of numbers? Big numbers, bigger than what on any of the three?
Well, and that gets back to what we were talking about is there's a lot of data out there, and I think that if you look at, like, go to the Space Weather Prediction Center and look at the map that they have up, they'll say, you know, they'll give you an S for radiation, they'll give you an R for radio, and then they'll give you, you know, the G for the geomagnetic storm.